Hello everybody, and welcome to the boat review of Boat Twente. Thank you all so much for being here. I'm Robin, I'm the team manager, and today, let me tell you a story. The energy transition is more important now than ever before. Not for likable reasons, of course, but sustainable sources of energy are wanted everywhere. This is a good thing, but we should not just want sustainable energy sources because of shortage reasons, but also to preserve the beautiful planet that we have right now. Sustainable energy sources are namely one of our big ways out of the climate change problem. We all know climate change is a huge problem for us, yet we cannot really grasp it because it is so big and it's even more difficult to grasp possible solutions. I experienced this myself as well. Some years ago now, I was standing in a bookstore trying to kill some time before my train arrived, and I picked up a book about climate change. I thought, as we are the unlucky generation of all, we might as well have to face this problem too, and maybe even solve it. I bought the book, I read it, and after it, I felt kind of hopeless actually. You see, the solutions that the book proposed were so big that I, for one, cannot start them. It did offer me one thing, though. It put me in front of a dilemma, a small thing I could do. Either I would never have to eat meat again, or I can never travel by plane anymore. I was kind of stuck because I really like both things, so I ended up choosing some kind of middle way by never buying meat anymore at the supermarket. It's a start, I suppose. Some years went by and I found this student team, Boat Twente, a group of young people together trying to solve the sustainability issue in the maritime sector. Even though I did not really know the problem we faced here, I thought, why not find out? What could be wrong, right? Right? Well, apparently a lot is wrong in the maritime sector, people. Let me tell you that. So, I'm going to throw a few numbers at you, so pay attention. 90% of today's trade is being carried by the maritime sector. 80% of the vessels carrying this trade is being powered by fossil fuels. Not only does this make the maritime sector a very big and underestimated cause of climate change, it also pollutes our oceans, which cover a riveting 70% of our Earth and its life. In today's world, we are bombarded with the consequences of climate change, so I won't bother you with those things like nature disappearing, not being able to grow food, overall chaos. You see what I did there? I did bother you with it because in our day-to-day lives we sometimes tend to forget, and this is logical because it all seems so far away and literally so far away from our happy and safe lives. But let me put it this way. In 2050, the governments want to cut emissions by the maritime sector in at least half, preferably more. So to make the problem a little more concrete to you guys, I will now do the same thing to you as the climate change book did to me. I'm going to put you in front of a dilemma. So listen carefully. Either you have to face the scary consequences of climate change. Yeah, that's option one. Keep option one in mind, scary consequences. Or option two, because we need to cut the sector in half, you can only get 45% of your normal food, drink, and web shop deliveries. Yes, that's option two. So option one, option two. I'm going to give you a few seconds to think about this, and after that, we'll have a vote. So think about this carefully, guys. No, I'm kidding. Lucky for you, there is a third option, and that is where we come in. Boat Twente, a group of 18 students together that are going to solve the sustainability issue in the maritime sector, and with that, save the world. Can you imagine? Probably not, or at least that's what I experienced in the past year. Friends, family, companies, even the sector asking me, how will you guys solve such a big problem? Please tell me, because I don't want to face the scary consequences, and I actually want both of my AirPods coming from China. Sit back, relax, because I will tell you. But before I do, I will need you to understand what it really is that we are making. Yes, a solar-powered boat trying to fly, but what is inside? What did we do to make this solar boat the most efficient and fastest one available? The team will tell you all about it, from the technical side to the road we had to take to come where we are right now. So before I come back to my question, how does this group of 18 young students solve the sustainability issue in the maritime sector and maybe even have the key to more? I now proudly present to you what this team has been working on so hard for this cause. Ladies and gentlemen, please enjoy the show. I present to you our boat, our growth, our way to a better world.
Hello, I'm Boris Veldbrugge and I'm part of the electronics sub-team. I hope you were also blown away by the stellar video made by Wilminktheater. Thank you. At least I was for the first time, and I still got a bit of goosebumps with this light show. And it showed also quite a lot of the boat. New team, new parts in the boat, also a new team name, the boat name, Rising Trident. The trident is seen as the most powerful symbol of the sea. That's because the Greek god Poseidon used it to rule over all the seas. The tri in our trident also has a double meaning, mainly because our hull consists of 3 floats, but also because we are the 3rd year that uses this current hull. Rising, of course, refers to one of our main goals, which is to fly out of the water. But, as probably many have seen, we have also gone through another change, a new main partner. As a new main partner, we have New Ways Electronics. Their expertise lays in creating electrical components, but also full electrical systems. With me, I have Hans and Enschede. Thank you for being here.
Congratulations.
Yes, thank you a lot. And first of all, I would like to bring out a toast to Christ and our boat. So,
One toast.
thank you.
Thank you.
Well, cheers.
Cheers.
Well, and Hans, tell me, what does the main partnership mean for you?
For us, it means a couple of things. First of all, seeing so many students working on topics like these, we really appreciate and value that as a company. And that's why New Ways supports a couple of these initiatives. And where it brings us, well, Robin said it's difficult to imagine where this will lead to. But this week I was reading that Lightyear now brings their first car to the market within a couple of months. We were also supporting the Stella car at the time, so it brought that from a same initiative now to a full company. That's what could happen, and we are happy to support that. Secondly, we have the option to have students and our teams work together on new innovative issues, and that's an inspiring thing for our teams also. And thirdly, it's just fun, I think.
Well, thank you. Great to hear. And you certainly also bring a lot of resources to the table. One of them is a lot of knowledge and expertise, of course, in the electrical field. And I, as an electrical engineer, really like it, of course. But I'm also working on the electronics of the steering wheel, which I do in quite close collaboration with New Ways. I have weekly meetings with the engineers to improve the circuit, the layout, and also to test it professionally, so that we can ensure that we have this year a reliable, race-worthy steering wheel. And Green, what do you talking about this year? What do you hope to see from us?
Of course, we hope to see that you are successful in the goals you want to achieve. But above all, we think it's important that we cooperate together in creating that better world you are talking about. And above everything, I think we hope that you can learn a lot and that you will have a lot of fun.
Well, thank you. Yeah, at this moment we already had, so that's already nice. I again want to thank you for being here, and I'm also looking forward to what this cooperation will bring us. And I think everyone is now also really curious what's actually inside this boat. So Roman and Camille will tell you all about the technical innovations we have gone through this year. So yeah, guys, take it away.
Well, good afternoon, everybody. My name is Roman. I'm the technical manager of Solar Boat this year. And next to me is Camille, who's part of the hydrofoil sub-team. Now, in the coming minutes, we will fly past all the innovations we have made for Rising Trident. But let's first start with some facts of our boat. The boat is 6.1 meters long, it's 1.6 meters wide, and 1.1 meters high. When fully assembled, it weighs approximately 130 kilograms. The top speed when sailing is 30 kilometers per hour, but when foiling, this could go up to 50 kilometers per hour. The range of our battery is, in bad weather conditions, around 25 kilometers, but in good weather conditions with a lot of sun, this could be almost 3 times as much, 70 kilometers. Now, these were a lot of numbers, so we'll slow down the pace a little bit and just run you through everything we've done by following the path of the energy. Well, as you might expect, our source of energy is, of course, the sun, and for that we use solar panels. This year, we have developed a new system for 2 of these panels. We use a more efficient type of solar cells, meaning they convert more of the sun's energy into electricity. Besides that, these panels are mounted on a carbon sheet. This makes it easier to take the panels off the boat for reparations or when transferring them to a future boat. And it also contributes to our goal of modularity. Now, after these panels have converted the sun's energy to electricity, this electricity goes to the battery, which is also renewed, and Camille can tell you more about.
Indeed, Roman. We still need power when there is no sun available. So therefore, we make use of our battery during peak performance, such as sprint, but also during bad weather conditions. An optimization has been made on the former battery. Then, as well, the electronic subsystem, the sub-team, has worked on a compact but structured battery design. Then, as well, if we look at the cable connections, they are all standardized. And this automatically entails flexibility in swapping components. I think you can all imagine that if we have to swap components as quickly as possible in between races, that is the key point. So if we look at modularity, this is the reason why. In conclusion, we can say that by working on the older, former electronic system, we now took a step further in making the whole system more reliable. So, looking at the electronic system, we still need power. We need to go forward. So how do we do that? Let's start with the backstrut. This year, we developed and manufactured the backstrut, keeping an eye on assemblability, efficiency, and again, modularity. The backstrut can be found at the bottom back of the boat, as you can see over there, and has the function to steer and propel the boat. After many hours of design, meetings with companies, you guys, feedback evenings with all team members, and a lot of coffee, this is the result. The customized motor inside of the backstrut has been replaced by an industrial motor on top of the backstrut. This makes it easier to repair or change the motor without taking the whole backstrut apart. So let's make a comparison right now. On your port side, you have the new backstrut. And on your starboard side, we have the older one. See the difference? Well, what you can actually see is that our new backstrut is a lot thinner. Thinner means less volume in the water and a more efficient drivetrain. Well, what we now house as well is a gearbox instead of this customized motor. Let me tell you how that works. The main motor shaft transfers the rotational energy in that gearbox to two different shafts for the propellers via a set of gears. Due to the orientation of the gears, the shafts spin in opposite direction. One other big feature of this gearbox is that we can also take the whole backstrut apart. We can perform maintenance without taking the whole drivetrain apart. Luckily, Roman knows more about the output of the gearbox, the propellers.
Exactly. As you can see, this year we've chosen for two propellers, and they are counter-rotating. This means that one propeller turns clockwise and the other turns counterclockwise. In that way, the second propeller cancels out the disturbances created by the first, and this improves the efficiency of our whole driveline. Another novelty of these propellers is that the metal is 3D printed. And this has three main advantages. The first advantage is that the accuracy is higher than with casting, another common production process. The second advantage is that by 3D printing, we have more freedom in creating different variations of the blades for various rotational speeds. And lastly, an important advantage of 3D printing is that it uses up to 98% less material than with milling. This works as follows. With milling, you start with a block of material and take away everything you don't need until the desired form remains. This is known as subtractive manufacturing because you take away material. With 3D printing, however, you start with an empty bed and build up the model with just the material that is required. And as you can expect, this uses less material. It's known as additive manufacturing. You add layers. Well, it uses less material, so it's more sustainable. Now, right behind these propellers is the input for our open-loop cooling system. And I hear you thinking, how do you keep your heads cool in summer? Well, not only our pilots are hot, but also the components in our boat can get pretty hot as well, up to 80 degrees Celsius. Well, they need to be cooled, so we are basically sailing in a lot of cooling fluid. We can use the water around us for cooling the components. You might think, well, salt water, electrical components, not really their best friends. So therefore, we use a combination of cooling techniques. The water comes in through the strut, where it's split in two channels. One channel going to the motor controller, and another channel going to the closed loop of our battery. This water then continues to the motor, after which the two lines merge and go out as one. Now, the input channels for this cooling system pass through a new component that Camille has developed called the golden disc. So, Camille, tell us more.
Well, of course we want to shine with a golden disc during our races, but that's not the only function it has to fulfill. Several components are housed onto the golden disc now, and even 3 shafts are going through the strut to the golden disc. So yeah, a lot of complexity. How do we do this? Let's build it up like a cake, layer by layer. We start with the tensioning system, which puts tension on the whole steering cable, so we can drive dynamically. Then we have the cooling Roman told you about. 2 tubes coming from the motors and 1 from the backstrut. They all have to be managed by a cable manager. Then we have the wing control lever. The wing control lever adjusts the back wing and creates space for the main motor. And this main motor is the top of the assembly and is connected via a coupling to the gearbox.
Now, about these tensioners, they tension the steering cable, which goes all the way to the front of the boat and is connected to our new steering wheel. And for this steering wheel, we have taken inspiration from Formula One. Besides just the mechanical function of a steering wheel, making the boat go left and right, this steering wheel also has an integrated circuit board with buttons. And these buttons can control different functions of our boat during testing and during races. Another novelty of this steering wheel is the red quick release mechanism you can see at the back. This makes it easier for the pilots to get out of the boat quickly when they need to. So, Camille, continue.
Yeah, I hope you're still with us, guys, because many terms. But let's do a quick recap. Until now, we've been looking at the power flow, so the energy flow, as a red line throughout our boat. But we're missing one big aspect. How do we make Rising Trident fly? Well, let's have a look at it. We make use of 2 front wings and 1 back wing. And with these wings, we create an upward force called lift, which takes the whole boat out of the water. So when the wings are still a little bit along the water, then there is no stability anymore. So how do we do that? I'll come back to that later. So yeah, I talked about this. Let's now see how the front strut actually works. So let's have a cross-section of this. We start with the push-pull motor, which is high and dry inside of the strut. This one is connected to a push-pull rod. This push-pull rod goes all the way through the strut. At the bottom, we have the wing, which is ratchetly connected to a nacelle. Still, the flap can move up and down via this push-pull rod. Talking about the nacelle, we experimented with some materials in order to see if we could take flying to the next level. So let me highlight some of them for you. If we talk about the nacelle, it's made from PEEK. And PEEK is a 3D printable material that is half as light as aluminum, but still has the same strength properties. Our flaps make use of a living hinge. And you're probably wondering, what does that mean? What is a living hinge? But I know you all have it in your fridge, and you know what it is, because it's in the ketchup lid. So we use the exact same principle to move our flaps up and down. Lastly, we have TPU membranes. And TPU is a weird, flexible, 3D printable material that we use in our membranes in order to prevent the push-pull motors from water damage. So let me come back to the question. How do we actually stabilize the boat, since there are disturbances, such as wind, waves, or even the propulsion of the boat? Well, in total, we have to stabilize 3 different movements: height, roll, and pitch. So, if you come home, guys, and people ask you, what did you actually learn at the Tech Talk of Boat Twente, you should at least remember one thing. Let's make it a bit more clear. Height, roll, and pitch. Okay, all kidding aside. When we go to Akron, the conditions for the water will be very mild. And for that, we can already use an industry standard control system, such as a PID controller. Maybe you're familiar with that. But if we go to Monaco, the waves will be up to 0.5 meter. And with that, we need a robust controller. If we make a physical model that predicts how the boat will behave in the water, and if we combine this with real test data, we'll hopefully bear the greater disturbances in Monaco.
Exactly. But for this control system, it's crucial to know the exact orientation of the boat. And for that, we use two types of sensors. The first type of sensor are the mechanical floats. These are the sticks you can see at the bottom of the boat with the red pedals. These pedals skip along the surface of the water and measure the distance between the water and the boat on each side. And from that, we can determine the roll angle of the boat. Now, next to that, we also use a sensor that measures the GPS and which has gyroscope, so it measures the angle in all degrees of freedom. Now, by combining the data from these sensors, we can cancel out the noise and get very reliable data of the exact orientation of the boat. And we can use that for our control system. Now, this was a lot of technical language, I understand, but I hope you have enough information now to build your own solar boat, everybody. Now, of course, it was enough for Camille and me now, so now let's listen to some understandable language about people from Femke and Wouter. Thank you all for listening to Camille and me.
So the last talk was all about the technical aspect of the boat. But we have to keep in our minds that without the team behind it, Rising Trident would not be here today. So we want to take you on the road that we have taken to get to all the technical advances that we have made last year.
We go back to September of last year when we just started with this challenge. We had no idea where we would begin on, so we just went with it. We didn't know what we could do, but we also didn't know what we couldn't do. What gave us a bit of structure at the beginning of the year was the race in Groningen. After just 1 month, we already had a race. But before we need to go to the race, we need to pack our trailer. And because we were so afraid we would need everything, we even packed 3 of the same tools because we were afraid we would need them. So, unfortunately, this made the trailer a little bit heavier than expected. And on our way to Groningen, we need to make an emergency stop on the highway because our trailer began to oscillate. Luckily, after redistribution of our trailer, we could continue our road to Groningen. When we arrived in Groningen, we needed directly to go to the technical inspection. During this inspection, we show the organization what our boat can do and if it's functional and safe. But because we didn't know exactly what we could expect, there were a lot of hiccups. But luckily, after this stressful first day, we could sail the following day. I was a pilot of the boat. And as a pilot, you are in contact with the strategic team. And they told me one thing: listen to us and just sail. But because I don't know what exactly was going on, but apparently there was a lot of chaos with the team. So every time I had someone else on the phone telling me different thing than the other.
I was on the other side of that phone as part of the strategic team. I was one of the persons talking to Femke. We had made a plan beforehand, but we had left a lot to the circumstances and to the weather. We thought, we can just set up our home base and then we can talk Femke through it. But sadly, after the launch of the boat, we didn't have anywhere to put our home base. So we had to jump on our bikes, we had to jump into the car, and we drove again to the city center of Groningen. There, with the 11-meter trailer behind us, we just tried to find a spot. Finally, we just settled by parking the car in the middle of the road, unpacking everything on the side of the road, and just settling down there and getting some structure. Still, this was a very stressful race. But one goal that popped up in our mind, and it was, well, we need to learn from it. We need to make progress. Or while we are talking our story here, it's maybe nice to introduce ourselves. I'm Wouter.
And I'm Femke. Together with 16 others, we attacked this challenge. Like I said at the beginning, we had no idea where we would begin on. And we had a long road, and we certainly have a long road to go. And also we had our ups and downs, and we will have more. But we know we can do it, so we will keep going on. And as a biomedical engineer student, you won't expect me probably in such a team, working on a technical team on a boat. But luckily for me, I don't have to do anything alone. So together with Tim, Anouk and Luc, we managed to make a fully functional backstrap design. And also with the manufacturers. And to finally feel your product and have it in your hands feels amazing. It gives you the confidence that you can do it together.
I'm an electrical engineer, which maybe is not that strange to see in a team that makes an electric boat. My motivation to join this year was to finally get my ideas and make them into a working project, to a working prototype. My second motivation was to work in a multidisciplinary team, to learn to work together and to get all that knowledge and put it into one project. During the first couple of months, also another motivation came to mind, and that was to make the most of it, to get to know this team and gain a great group of friends. I think what really brought the team together was celebrate every little achievement. We celebrated finalizing the budget, assembling the battery, sending the final drawings to the manufacturer. We also celebrate every birthday with cake and singing in the office. But not only the fun parts brought us together, not only the celebrating. We had to do a lot of testing, and we still have to do a lot of testing. And every time at the testing, well, we discovered that a component would not work correctly as it should. So frustration became a big part of it, especially with a high pressure to make something that could really perform. Especially for our control engineers. For them, every part of the boat needed to work correctly to test. So every time something broke, they had to wait until they could run tests again and evaluate their models. But with trying again and again, and with falling and rising again, literally with a flying boat, we will keep making progress and we'll keep celebrate every little achievement.
Today, we show you Rising Trident. This boat embodies what we have achieved so far and that we are ready for the races to come. We still have a long road ahead of us and we will keep giving all we can. We learned a lot from the technical aspects and for most we learned a lot from each other. We keep giving everything we can and we gave everything we can and we will keep giving all we can.
So, I wonder everybody, did you get some time to think about the question I propose? How will a group of 18 students together solve the sustainability issue in the maritime sector? I hope you've been able to come up with a thing or two, but it might still be very abstract, and I understand. You see, what I did not yet tell about myself when I was picking up a book about climate change was that I did not just pick up the book to get some more information. The fact is that the problem of climate change is a very scary one, especially for us as youth. People still joke around with it a lot, and the action we need to take, like switching to sustainable energy sources, is well on its way, but still far from accepted. This can make me feel a feeling of fear and sometimes even loneliness, and I can understand if it makes you feel like that too. You might ask yourself questions like, do I have to sit back and watch all of these things happen to me or to my future children? However, step by step, Solarboat has shown me a path towards a more sustainable maritime sector, and with that, maybe even a key to more. So, to relieve you from your possible doubts, how will a group of students together solve the sustainability issue in the maritime sector? Well, sadly, we will not solve the issue right away, right now, with this boat. But I do believe the solution to these problems is in projects like Solarboat. The reason for that is twofold. The first one being a technical reason. At the moment, we can't power these big vessels with solar energy. It simply costs too much power. But what if you need less energy to power these ships? Efficiency is a big part of the answer here. With our boat, we try to show that with the little energy we get from the sun, we can sail super fast and efficient. With the efficiency wins we make, we hope to inspire big maritime companies to do the same and to use less energy so emissions will automatically drop. The second part of the answer is actually not technical at all, and this is something that surprised me. The corporate world right now is made to make short-term profits. You need to make a lot of money in order to be successful. These short-term profits are at the moment not in sustainable techniques. They are just not. It's too expensive. The culture and the values of these big corporate companies are thus not made to make the world more sustainable quickly. So, what if you put together a group of young minds that simply do not care about making profit, only about looking for innovation and looking in every way they can to make new things? What if this group also does not really care about making mistakes and the stakeholders do not punish them for making these, but encourage them to learn and to look even further, to throw the anchor as far away as you possibly can? Then you have a group that can make a difference. With the difference we make, we hope to inspire other companies to follow our philosophy and look on the long term. Look what you can do. Together, not alone, we can do this. And in that light, I would like to thank all of our partners that helped us build this boat, because without you, we couldn't have done what we have done today. Because our partners believe in us and they believe in a sustainable future. I would also like to thank the organization of this event. Veerle, Sam, Robin Kreuger, thank you for your relentless hard work in the past few weeks. The Wilminktheater, of course, thank you for lending us this beautiful stage. We are very happy that we are finally able to tell our story to a very big and live audience after Corona. Jorik, of course, thank you for all your efforts and for your mentorship throughout the year. We also could not have done this without you. I hope we have shown you how a group like this can make an actual difference in a sustainability problem in the maritime sector. I'm very proud to stand before this group, seeing how they all have grown and what they all have achieved. Luckily, this is not the only moment they can show what they have achieved. In the end of May, we have the Open Dutch Championships in Akrum, and in the beginning of July, we'll have the World Championships in Monaco. If you want, you can see how we can inspire you if you follow us on our social media channels or on our website. I hope after today we leave you with a little bit of more trust in the future. Because if you ask us, the future will be great. Thank you very much.